Hello everyone, this is Kayla from the Math Center, and I'm just going to talk to you today about the value of the graph f, the values of its derivative, and the value of its second derivative. And these are all things that you can just understand just by a graph of the original function f of x. So these are definitions that you will use to try and figure out, okay, what is the value, and by value I mean, is the graph positive, is it negative, is it equal to 0 at different points in the graph. And so this is our graph f of x. This is our original graph, and this is positive when the graph lies above the x-axis, and it's negative when it lies below it. The only time it's not it's neither positive nor negative is when it's directly on the x-axis, and that's when it's 0. So this is also, for example, this part of f of x, this part of the graph is all positive, and then you have this whole negative interval here, and then the whole graph is also positive in this interval. And so it's only 0 at these 2 points when it crosses the x-axis. So, but you can also tell when f prime of x is positive, negative, or 0 just from the graph f of x. So from this definition here, you can see that f prime of x, f prime of x is positive when the slope of f is positive. So so you just need to look on the graph, and then you just need to visualize a slope along each curve of the graph to see if the slope is positive or negative. So for example, on this part of the graph here, from here to here, you can see that if you run a line glancing like just tangent to the curve along each part of this graph, you'll see that your slope is positive. And so this whole interval here, for the slope f prime of x on this graph of f of x is all positive. And so and then f prime of x is negative when the slope of f is negative. So for example, from here to here, this part of the graph, you can see that if you draw a line tangent to the curve along that whole part, you'll see that it's a negative slope. And then and so where you'll get f prime of x is 0 is when the slope of f is 0. So these are where your mins and maxes are. So here's one, there's one, and there were two. So we have four places where your f prime of x is 0. And then we get to f double prime of x. So at this point, we're looking at concavity. So here we were looking at the value of f of x. Here we were looking at the slope of f of x. And now here we're looking at the concavity of f of x. And so f double prime of x is positive when f is concave up. So when you have, your smiley face. So like this interval here, you have a big old smiley face where f of x is concave up. And then f double prime of x is negative when f is concave down. So for instance, this right here, this interval right here, you have a giant old grumpy face. And so that's where f double prime of x is less than 0, so negative. And then here you have a slight concavity too, negative concavity. So you have your concave down there. And then the only place where f double prime of x is 0 is when you're changing from concave up to concave down. So like, for example, here along here, you went from concave down to concave up. So you have, this is where, somewhere along this region is where f double prime of x is 0. And then here you have another change of concavity where you're slightly concave up and then you're slightly concave down. And so this change here is where f double prime of x is 0. And so this is just things you can find out about your function f of x, and then it's first derivative and second derivative, just to tell you a little bit more about the function if you need to solve a problem. So now we're just going to test out a few points on this graph. And so you may get a question like this, or this will help you solve a question where they want you to tell them stuff about your function f of x on the graph. So so you may get a question like, for every point, describe what is the state of f of x and why. It's not enough just to say, okay, you can't just like guess and then be like, well, I think that's the answer. No, you have to describe why. So so we're gonna look at A, B, C, and D. So at A, you have, so here, what is the value of f of x? Is it positive, negative, or 0? And so here we know, based on our definition, that it's positive. When f lies above the axis, it's positive. So, yep, it's positive. And then f double prime of x. So we know that, we know here, just looking at it, that the slope here is negative, because if you draw a line, right, tangent to it, it's a negative slope. So we know that the slope is negative when f double prime of x is also negative. So when it's less than 0. There, it's negative. And then, and now at this point in the graph, we know that it's concave down, and we know it's concave down when f double prime of x is less than 0. So that's also negative. And then, so that's all of A. And now for B, we know that it lies below the x-axis. So we know that it has to be less than 0, so it has to be negative. Now, the value of f prime of x at B, we know that here our slope is 0. Because if you draw the tangent line, it's exactly straight, horizontal tangent. So the slope is 0. And that only happens when f double prime of x is 0. And then for f double prime of x, we know that the graph is concave up. So in order to be concave up, f double prime of x has to be positive. So there you go. So now at our point C, C is a special case just because it lies right at the tip of something we call a cusp, and so it's kind of weird. So we'll see. So at C, we know that f of x. So at C, you lie above the x-axis. So your f of x has to be positive. But now when we try and look at its derivative and its second derivative, it kind of turns a little bit weird, mostly for the fact that your derivative doesn't actually exist here. So not only does this derivative not exist, the derivative from the left-hand side and the right-hand side also don't exist. So it just doesn't work out. And because this doesn't exist, you don't actually have to worry about your f double prime of x, because you can't have a second derivative if you don't have the derivative, you don't have the first derivative. So this also doesn't exist. So but that isn't to say that here you don't have positive slopes and here you don't have negative slopes, and here you're concave up and here you're also concave up. It just gets weird when you approach C, so be careful. Here and here you can still say stuff about the slope and the concavity. You just can't say it when you approach Z, or when you approach C, or when you're at C. So now for our final points, we're going to look at D. So at D, we lie above the x-axis, so we have to be positive. And so then our slope. So our slope here is positive. If we draw a tangent, it's a positive slope. So we know that can only be true when our f prime of x is positive. And then at f double prime of x, now here's the cool thing. Right here, we changed from a positive concavity to a negative concavity. we're concave up and then we go concave down. So that change means that our f double prime of x is 0 at this point. So there you go. So yeah, these are all things you can learn about these separate points just by your graph f of x. Hope this helps, and see you guys in the Math Center.